In this video, we are going to discuss a very important part in definite integral, that is properties of definite integral. Okay, now you are going to have one 4-mark question definite based on these properties of definite integral. Okay, so here we are going to look at the properties. All right, so properties of definite integral. See, when we look at the properties, there are around 7 properties. Okay, now if you consider from 0, or you can say that there are 8 properties. Now, in these 8 properties, some of them are quite obvious and some of them are a little, you need to understand the math behind it. All right. Now, in this case, so the first property what you have, the very first property, suppose if you have integral from a to b f of x dx, the property tells you that if you change the variable of the given integral, then the integral is not going to change. In the sense, this is equal to integral. Suppose if you write f of t dt from a to b, both are one and the same. In the sense, if you change the integral from x to t, the integral value is not going to change. So this is what we call this is the first property. So this property is the change in the variable property. Fair enough. Now the second property what you have, second one, suppose if you have integral f of x dx from a to b. Now if the limits are interchanged, then we introduce a negative sign. That means if you have minus of b to a f of x dx, this is the second property. Now there is a very simple proof for this one. Very simple proof. See, f of x, the LHS if you take, this is nothing but f of b minus f of a, correct? This is how we defined integral, isn't it? So this you can also write it as minus of f of a minus f of b, isn't it? So when you write minus of f of a minus f of b, this is nothing but minus of integral b to a f of x dx, because the upper limit is a and the lower limit is b. So you are going to get this. See, this is the proof, very simple proof, correct? Now let's do the third one. See, the third property what we have, third property. Now actually this is quite an important property. Okay, so we have integral from 0 to a f of x dx. Then this is nothing but integral from 0 to a f of a minus x dx. Now this is the property, this is the third property. Now there are n number of problems where we use this property in solving, especially when you have trigonometric functions such as sine and cos. We use this particular property. All right, so this is the third one. Let me show you an example. See, here I'm not solving the whole thing, but I'll show you how we apply this property before you start with problems. Okay, suppose say you have integral of, let's say, log of cos x dx from 0 to pi by 2. All right, let's call this as I or something like this. Now we apply this a minus x, that is property 3. So what you will have is I is also equal to 0 to pi by 2 log of cos of pi by 2 minus x, which becomes integral log of sin x. Correct? Log of sin x. Now we can add these two integral. So we will have 2i. That is, we are adding this one and we are adding this one because both are I only, right? Will be 0 to pi by 2 log of cos x plus log of sin x. Further, we can simplify and we can integrate. Understood? So I gave you this example to show you how we are going to apply the third property in the problems. Understood? So this is how we are going to do the third one, as in the third property. Fair enough? Now let's do the next one. That is, we are going to do the fourth property. The fourth property, what you are going to study now. See, this is more like the general property of the third one. Okay, let's see what you just saw, the third property. Fourth property is a general case of the fourth property. Sorry, third property, right? In the sense, here, suppose if you have integral of f of x dx from a to b. Now, this can also be written as integral from a to b f of a plus b minus x dx. Okay, now let me show you the proof here. Okay, and you can also see, say very easily, you can say that this is a general property and the previous one is a specific property. Because see, this is why I say that this is a general one, because suppose if a value becomes 0 and the upper limit b value becomes a, don't you think you're going to get the previous one, that is the third property? So if you know the proof of this one, the previous proof is also the same, very similar, isn't it? So what we do is we do substitution here. That is, we'll take a plus b minus x as t. So you will have minus dx is equal to dt, isn't it? So we are going to apply that here and we are going to do it. That is, see the RHS, integral from a to b f of t minus dt, isn't it? So when you take this one, minus integral a to b f of t dt, isn't it? So when you have f a plus b minus x as this and minus dx is this one, so now what we are going to get, we have integral f of t from a to b with a negative sign, correct? Now see, when you're doing substitution, remember you also have to substitute, as in change the limits also, isn't it? So when, see, a plus b minus x is t, when x is equal to a, what do you have? When x is equal to a, t is equal to b, and when x is equal to b, t is equal to a. So the integral what we have here, that is true, but the limits is going to, both the limits are going to change, isn't it? When you change the limits, you have integral minus b to a f of t dt, which is nothing but integral a to b f of t dt. Remember the first property, you can change the variable, right? So this is going to become integral from a to b f of x dx. Isn't it the what we have in the LHS? So LHS and RHS are one and the same. Now let me show you an example. Suppose say you have integral from pi by 6 to pi by 3. Let's say sin x divided by sin x plus cos x dx. Say this is I. Now we can use the fourth property what we just studied right now. Because see, if you are going to apply that, then you will have I is equal to integral pi by 6 to pi by 3 sin of pi by 3 plus pi by 6 minus x by sin of pi by 3 plus pi by 6 minus x plus cos of pi by 3 plus pi by 6 minus x, correct? What is pi by 3 plus pi by 6? It's pi by 2. 30 plus 60 is 90. So we are going to get this as I is equal to integral pi by 6 to pi by 3, sine of pi by 2 minus x, which is cos x by cos x plus sine x. Now we can add and we can simplify. See, again, I'm not solving the whole thing. I'm just showing you an example as to how do we apply this property in the problem. Make sense? So, whenever you have these kind of problems where you have limit upper and lower limits both, then you can apply this particular formula and you can solve it. Understood? Now, let's go for the next property. See the fifth property what we have. Suppose if you have integral from a to b f of x dx. Now, this you can split it as integral from a to c f of x dx plus integral from c to b f of x dx. Remember, c is a point between a and b. So that means c is between a and b. This is a very, very important part. Okay. Now, let me show you an example. Then maybe we can do the proof so that you will understand. The proof part is quite simple, yeah. See the RHS. You have f of c minus f of a, correct? The first part. Plus f of b minus f of c. F of c cancels. What do you get? F of b minus f of a. Isn't it what we have on the LHS? So proof part is very easy. That's what I was trying to tell you. Let me show you an example for this one. Okay. Now this case we use in certain type of modulus function, square root function, like these kind of functions. Say you have a function, say I is equal to integral minus 1 to 2, say mod of x. Let's just take mod of x for now. Now, if you remember the modulus function, it goes like v, isn't it? So the modulus function, it goes like this. There is no negative term whatsoever. Even if you take x as negative, y is still positive, correct? But how do I differentiate minus 1 and plus 1 for the value of x? Because y value is not going to differentiate, isn't it? Mod of minus 1 is the same as mod of 1. Both are one and the same. So, while integrating, we need to differentiate it. Because integration meaning what? It's the area under the curve, right? That's the meaning of definite integral. So, if you are going to take it that way, then we have to split the integral. In the sense, we need to split the limits of the integral. So, how we are going to do is, first we take I value from minus 1 to 0. Here the integral value is minus x because it's in the negative side, plus 0 to 2 x dx. Fair enough? So understood why we are doing it this way. From negative 1 to 0, the value of x is negative. So we take the negative limit. So you split the limit. Just like the property what we have from a to c and c to b, minus 1 to 0, 0 to 2. Fair enough? So this is an example for the fifth property. Fair enough? Now let's go to the sixth property. See the sixth property. What you have is integral f of x dx from 0 to 2a. Alright, 0 to 2a. So this is given by integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Understood? So this is the integral what you have. Now first let me show you the proof. The proof of sixth one is actually very simple. So what we do is we start from the RHS. That too we start from this one, the second one. Okay. See what we are going to do. So we'll start by taking 2a minus x is equal to t. Okay, very simple. So x is equal to 2a minus t. Right. Now what do? Change the limits. Suppose when x is equal to a, t is equal to a, correct? When x is equal to 2a, then t is equal to 0, right? So to get this particular integral, what we do, see the LHS, we split it, we split the limit. In the sense, what we are going to do now is LHS, which is 0 to 2a, f of x dx is 0 to a, f of x dx, integral a to 2a, f of x dx. Now take the right hand side. Okay, only the right hand side, that to the second integral on the right hand side. So what do? Take x as 2a minus t. So you have integral f of 2a minus t into minus dt. Dx becomes minus dt, isn't it? Now the limits will also change. The limit is going to be a to 0, correct? So when you change the limit, when you flip the limit, minus becomes plus. So this is going to be integral 0 to a f of x dx plus integral 0 to a f of 2a minus t dt. Remember the first property where you can change the variable. So from t we can change to x. When you change from t to x, don't you think we are going to get back what we were trying to prove here? Correct? So this is how we are going to prove the sixth one. Now the seventh property which we are going to discuss now is very similar to this one. You are going to have two cases. It's more like you can say it's continuation of this one. All right. See the seventh property. You have integral 0 to 2a f of x dx. So this we have two cases. This is 2 times 0 to a f of x if f of 2a minus x is equal to f of x, or 0 if f of 2a minus x is equal to minus f of x. And I think it's pretty obvious because if you look at the previous result, we are adding that, correct? See, what you know from the previous result is that f of x dx from 0 to 2a is what? Integral 0 to a f of x plus integral 0 to a f of 2a minus x dx, correct? Look at the cases. If f of 2a minus x is equal to f of x, then it's 2 times, quite obvious. If it is negative sign, then these two will cancel out. So answer becomes 0. That's all. Very simple proof. Fair enough? So this is the answer for the, not so answer, more like proof for the seventh one. Now we'll look into the last property of definite integral. All right. See the eighth property. The property says if you have integral f of x dx from minus a to a, again this has two cases. Okay. That is 2 times 0 to a f of x dx if f of minus x is equal to f of x. That means it's an even function, or 0 if f of minus x is equal to minus f of x, which means it's an odd function. Understood? So if it's an even function, you add and you're going to get 2 times. If it's an odd function, it's going to cancel out and you'll get it as 0. That means now we need to prove it. Guys, the proof is also very, very simple for this one. Okay, so what you're going to do is we'll have to split this one. Okay, so we'll split just like what we did in the sixth question. It's very similar to that one. Understood? It's very, very similar to that one. So what we are going to do now is take this one minus a to 0 f of x 0 to a f of x. Right? In this one, what you do is here take x is equal to minus t. So dx is equal to minus dt. The limits will also change. When x is equal to minus a, t will be equal to a, because minus of minus, no? When x is 0, t is 0. This is one and the same. So now it's going to change. Integral from a to 0. Then f of minus t to minus dt. Or integral from 0 to a, f of minus t dt. Now what did we learn from the first one? You can change the variable. So what do you get then? So you're going to get this as 0 to a, f of minus x dx, correct? So what did we get? This particular integral can be rewritten as 0 to a, f of minus x dx, right? So don't you think if it's an even function like this one, you'll get 2 times because both of them are gonna add up. Suppose if it is an odd function like what we have here, then these two will cancel out. You will get it as 0. Understood? So this is what we have as the properties of, this is the last property. So these are the properties of definite integral. All right. So as you can see on the screen, this is the summary of all of it. Fine. Please go through it. And once you're thorough, in the next video, we are going to do few example and problems based on these properties, what you have learned so far. So in the next one, you're going to see few problems on these properties.